If you look at the first page of your probability packet, we are going to do a review of probability. Now, I know you've done this quite a bit in the younger grades. So the probability of an event is the measure of the likelihood or the chance that the event will occur. And you can express probability as a decimal, fraction, or percent, but probability always is between a probability of 0, which means it's impossible, to a probability of 1, which means it is certain. Not just likely, but certain. Okay, so we're going to look at some probabilities and just use words like likely, unlikely, certain, impossible, or just as likely as not. Okay, so if we look at page 1, and if I say to you, if the probability is 0, then it is impossible. So you fill in impossible there. And if the probability is in between 0 and 49%, then it is unlikely. This was impossible. 50% means it's just as likely as not. Above 50% is likely. And a probability of 100% is certain. So again, probability ranges between impossible and certain. So it ranges from 0 to 1. Okay, now we're going to start out with experimental probability. An experimental probability is a way of estimating the probability of an event. The experimental probability of an event is found by comparing the number of times the event occurs to the total number of trials. So, for example, if we look down at number 1, this says, Tanya made saves on 15 out of 25 shots. What is the experimental probability that she will make a save on the next shot? So, the number of times that she made a save was 15. Over the total number of times she tried was 25. So 15 out of 25 is the probability that on the next shot she will make a save. Now, that we can also write as 60 over 100, which is 60%. Or 0.6, or we could simplify this to 3/5. Okay? Now, number 2. Number 2 says that the temperature for the past 10 days has been either 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Any of these 10 temperatures. What is the experimental probability that tomorrow's temperature will be above freezing? Well, above freezing is anything above 32. So they're basically saying out of these 10 temperatures, how many are above 32? Well, 34 is and 45 is. So 2 out of 10 are above freezing. So that's a probability of 20%, or 0.2, or 1/5. Okay? Now go ahead and turn the page and try the next one on your own. Okay, if you're not done with the next one, just stop the video, but I'm going to go over the next one now. This says George was throwing free throw shots in basketball. He made 20 out of 25. What is the probability he'll make the next shot? So 20 out of 25 is 4/5. That's probability. 80% or 0.8. Okay? Now, the next thing we're going to go over is complementary, what it means to be the complementary event. Now, in probability, you have the probability of getting, let's say, throwing a coin and getting heads. And the probability is 50%. So if the probability of getting heads is 50%, the probability of not getting heads is also 50%, because two complementary events have to add up to 100%. So let's look at the Jolly Ranchers to get a better example. If there's 20 Jolly Ranchers in a bag, 5 are blue, 4 are grape, 3 are cherry, and the rest are green apples. So first let's figure out what the rest would be. That would be 8 green apple. What's the probability of getting green apple? Well, it would be 8 out of 20. What's the probability of not getting green apple? Well, it would have to be 12 out of 20, because 8 out of 20 plus 12 out of 20 has to equal 1, because these are complementary events. Either you get a green apple or you don't get a green apple. So together, it has to be 100%. So this I would write as 2/5, and this I would write as 3/5. Now, what's the probability of getting cherry? Well, there's 3 cherry out of 20. What's the probability of not getting cherry? Has to be 17 out of 20, because 3 out of 20 plus 17 out of 20 has to add up to 1. Now, what's the probability of getting blue or grape? Well, blue or grape would be 5 plus 4 out of 20, or 9 out of 20, which means not getting blue or grape must be 11 out of 20. Okay? Now, the next thing we're going to go over is theoretical probability. And theoretical probability is different from experimental probability, because we don't actually do trials. We just base the theoretical probability on actual math. So it doesn't mean we actually rolled the dice, but we would know the probability based upon using math. Now, theoretical probability is the number of ways an event can occur, or successes, over total number of outcomes. So if I do roll a die, and a die has 1, 2, 3, 4, 5, or 6 on it, and I say, what's the probability of getting an even number? Well, I can get an even number if I roll a 2, a 4, or a 6. So 3 ways to get an even number, and there's 6 possible outcomes. So it'd be 3/6, or 1/2. Now, here we're going to go over a standard deck of cards, and unfortunately you guys don't play cards like you used to. So I'm going to explain what's in a standard deck of 52 cards. In a standard deck of 52 cards, we have 26 red cards, 26 black cards. Half of the reds are hearts. Sorry, so there's 13 hearts, 13 diamonds. There are 13 clubs and 13 spades. Okay? And there is a 2 of hearts, of diamonds, of clubs, and spades. There's a 3 of hearts, 3 of diamonds, 3 of clubs, 3 of spades, etc. So every card exists in all different suits. So what is the probability of me drawing a 2? Well, there's 4 2s in a deck of cards. So the probability of getting a 2 would be 4 out of 52, or 1/13. What's the probability of drawing a red card? Well, there's 26 reds at a total of 52, so it'd be 1/2. How about the probability of getting a diamond? Well, there's 13 diamonds out of a deck of 52, or 1/4. And what's the probability of getting a red 2? Well, there's 2 red 2s and 2 red blacks, so it'd be 4 out of 52, which is 1/13. Okay, so now I want you to go ahead and stop the video and try to finish this page. When you're done with this page, turn the video back on again and see if you got the right answer. Okay, so it says Mr. Rose draws names to see who will give the first book report. There are 10 boys and 14 girls. What is the probability that he'll draw a girl's name? Well, there's 14 girls, and there's 24 students in total, so the answer would be B. Now here, 8 students are giving reports on novels, 9 on biographies, and 7 on history books. So there's a total of 24 students. 8 of them will report on a novel, so that's 8 out of 24, or 1/3. Now, Stanley is reading a 224-page book. There's illustrations on 14 pages. So 14 out of 224 would be illustrations. So the answer is A. And in Congress, there are 50 states, and each state has 2 senators, so there's 100 senators. If you choose a senator at random, what is the probability that you will choose a senator that represents Virginia? So there are 100 senators, and 2 are from the state of Virginia, so 2 out of 100, or 2%. Okay, so then, for the final ones, there are 6 yellow cards, 4 blue cards, and 10 green cards in a bag, so there's a total of 20. I'm going to put 20 as my denominator for all of these. What's the probability of choosing a yellow? Well, there's 6 yellow out of 20, so that's 3 out of 10. A green, there's 10 out of 20, so 1/2. A blue, there's 4 out of 20, so 1/5, and a blue or green is 14 out of 20, or 7/10. Okay, so now I want everybody, you're going to do 2 things. You're going to either complete page 4 of the probability packet, and the answers are posted in Google Classroom. I posted the entire answer packet. Or you're going to do corrections on the Chapter 3 test, or you're going to work on page 940, which is a review of solving equations number 1 through 25 odd. So for the remainder of the period, you're either going to do quiz test corrections, do the probability packet page 4, do the textbook page 940, or you can do number 1 through 9 on the take-home quiz.